Hi, everyone. Thank you for the intro. And I'm a PhD student from IMDEA Networks, Spain. I work mostly on security and privacy threats in smart home and mobile ecosystems. In this work, I'll be talking about characterizing local network communication and threats associated in the smart home ecosystem, which was done in collaboration with folks from IMDEA Networks, UC3M, Northeastern University, NYU, Berkeley, University of California, Berkeley, University of Calgary, and absences. So straight off the bat, last year I got obsessed with making my home smart. It started by just adding a small, smart light bulb, and I set it up, connected to the internet, and I realized that I could, control it with my smartphone. But I didn't end there. I wanted to go all in, and I decided to set up a smart TV, then a camera, and then a voice assistant. Soon I found out that these devices can also communicate with each other in my local network. For instance, I can watch my camera's live stream or sync my home lighting with what I was watching on the TV. So it's pretty cool, right? But as a security and privacy researcher in me, I started to wonder if this communication or this network of communication that exists, which provides you with handy set of features, but is this really safe? And they enable a continuous and seamless interaction, and whether it's privacy safe. So that took me to the scientific literatures that exist, and to understand what has been understood so far. There has been a tons of research that has looked into what happens between the communication across the device and the cloud. There is also tons of research that looks into what happens from the app or the mobile device and and to the device itself. But there's a lack of understanding on what happens within the local network and what sort of local communication and threats that exist within the local network. But one might argue that all of these devices are behind a NAT, and these devices are protected from external threats. But that's not enough. Due to broken local network privacy protections and local environment not being a trusted execution environment anymore. So hence, devices can actually broadcast sensitive information in the local network, assuming the same that local network are a trusted execution environment. And such information can be easily exfiltrated by co-located apps or co-located devices, and then can be used for cross-device tracking or unique household fingerprinting, or even inferring your socioeconomic status. We found several companies or multiple parties doing this, and which were collecting this sensitive information and exfiltrating this information over to their cloud, which I will show throughout the talk. So to understand this ecosystem better, we ask 3 research questions, starting off with what are the characteristics of smart home local network communication, what are the privacy and security threats associated with them, and is local network communication being abused for fingerprinting and tracking purposes? To set out to answer these questions, we built a testbed of 93 consumer IoT devices, which spoke IP-based protocols. For this particular research, we ignored other wireless protocols such as Bluetooth or Zigbee for future work. We captured all the local network traffic and interactions with these devices during an idle period and also during interactions. And also to provide more interactions and real authentic responses to these devices, we set up a honeypot and also an active scan to issue authentic responses from these devices. In addition to that, we also set up a mobile app devices instrumented to collect local network behavior in the smart home. With our instrumented Android phones, we performed both network and runtime analysis to capture unencrypted traffic on more than 2,000 mobile apps, both on IoT-specific ones and non-IoT-specific ones. While this testbed gave a in-depth understanding of what happens in the local network. We also wanted to see how in breadth in the wild what happens. So to do so, we crowdsourced IoT local network traffic from 12,000 IoT devices across 3,000 households from 264 unique products. With that setup, we started to investigate how these devices interact with each other. So this network graph shows you how these devices interacted among themselves in the local network. Each nodes represent different devices, while the edges represent the protocol that they used for communication. A symbol line represent TCP communication, while dotted line represent UDP, or if there's a thick line, it represents the usage of both. With that, we found that they were using 35 different protocols for communication, and nearly half of them were communicating via unicast for either a command and control services. And we also found 93 devices were using broadcast-based protocols. 73% of these devices were using multicast as well, for mostly interoperable features and whatnot. Zooming into the more connected part of this graph, we found that there are intra-vendor communication across devices from same ecosystem, such as Apple devices communicating with Apple ecosystem. And also there is an inter-vendor communication, probably for interoperable features such as casting or using open source protocols. So with this, we established that these devices are actually super chatty in the local network, but we wanted to understand what are the privacy and security threats associated with them. We saw that these devices were broadcasting sensitive information into the local network. For instance, the Amazon Fire TV was using UPnP or SSDP to share the device name or username and several persistent UUIDs into the local network. Or also there was like this TP-Link bulb, which was sending out a geolocation through their custom TP-Link SHP protocol. And most interesting fact is that all of this was in plain text. So any co-located app or a device could actually listen to this and siphon it off to their servers. We also found more details about this ecosystem and what all do they collect. This work is done as a part of academic research, which was published last year in ACM IMC. So feel free to check out the paper, which has the same title as the talk, and I'll have the QR code embedded in the last slide as well. So far we have established that these devices are super chatty and they are sending out sensitive information in the local network. And we wanted to understand that whether these apps or devices co-located within this local network, are they actually extracting certain information or not? So for that, we specifically turned our attention to Android apps and third-party code that's embedded in them. So we find that Android apps can actually easily exfiltrate local network information without any permission or without any user consent. So apps and SDKs can actually scan the local network and collect information exposed by the smart devices without any runtime permissions that request for your consent. This essentially bypasses the permission model that exists in the Android ecosystem to collect sensitive information such as the Wi-Fi, SSID or BSSID, which can also be a surrogate for your geolocation because there exist several databases with this information out there. We also turned our attention to iOS, but luckily local network scanning in iOS is a bit too constrained. So developers need to ask for explicit consent and approval from Apple itself to access multicast sockets. And they require explicit permission from the user as well to actually scan the local network. So again, we established that these devices are actually super chatty in the local network. They are sending out sensitive information in the local network, and apps and third-party SDKs that exist in the local network can actually collect this information. But is this actually happening in the wild? Turns out it is. So we found two cases that I'm going to talk about here today. One is where one of the device was collecting Wi-Fi SSID and BSSID, to which it was connected to, and then it was using MDNS to just broadcast this information in the local network. and apps which were scanning the local network was able to collect this information and bypass the permission model that Android set up and then send it over to their cloud infrastructure. One example of this is App Dynamics and Analytics and Profiling SDK, which we found to collect all the SSTP or UPnP messages, which had the device name and the MAC address, which are sensitive information. Another instance that we found was where devices were sending out malicious UPnP or MDNS broadcast. Sorry, the apps were sending malicious UPnP or MDNS broadcast to these devices in the local network, and these devices bluntly responded with several device PIIs, which included MAC addresses or Wi-Fi BSSIDs and SSIDs, and which in turn the apps collected and then send it over to their cloud infrastructure. So here there is two examples that I want to show. One is an SDK called Umlaut in Core SDK, which was crafting specific SSID and UPnP messages and collecting these information from them. And then another example is Inno SDK, which is like a third-party anti-cheating and advertising library, which interestingly was using NetBIOS to request every IP and information related to that in the local network and send it to its endpoint. This library was later on classified as a malware, and Google, after our report, Google actually kicked them out of the Play Store essentially. Yeah, all the apps that contain this SDK has been removed from the Play Store. So once these apps or any entities that collect this information, we wanted to understand that whether this local network or device information that these apps or SDKs or devices can collect, can they do some sort of a household fingerprinting? To do so, we looked into our large-scale data set collected from the 12,000 devices, and we specifically looked at three types of identifiers, such as the names, user names or device names, and UUIDs and MAC addresses. To understand if they can be used for fingerprintability, we use a particular metrics defined by Electronic Frontier Foundation called entropy to measure fingerprintability, and which means that higher the entropy indicates greater fingerprintability. And we found that exposing all three identifiers make your household highly distinctive, which means that just by three different identifiers, a person can know who you are. And from our data set, we found that 2,800 households exposed UUIDs, and 94.2% of these households can be uniquely identified. After our analysis, we disclosed all our findings to different vendors and even Google. We reported the side channel to Google. They rewarded us with a bug bounty for our findings. We provided the list of misbehaving apps to Google, and also we reported all the IoT behaviors to several IoT vendors that was doing this. We also contacted several regulators in our jurisdiction, such as since our labs in Spain, we contacted APD. We had collaborators from the US, so we contacted FTC, and they all acknowledged the problem, and they acknowledged that this is a real threat. We also got several responses from the vendors suggesting that they will be including a new identifier. For instance, they will be including a new identifier at random to replace the current persistent UUIDs. And Google also has been really great at engaging with us to acknowledge that this is a real issue and harms user privacy. They also propose several mitigations, such as they'll be implementing new permission model in the Android OS. They will be including a new app review process, and also they will be including this in the general IoT standardization efforts as well. I want to emphasize that this attack is not exclusive to Android. Other in-network adversaries, such as the one I have listed here, other IoT devices or smart TV apps, or even any visitors that come into your house and connects to your router and your network, can also compromise your information. And we need more and continuous research, and tooling is needed to understand more in depth what happens. And IoT devices are very hard and expensive to test. So we need more research to go on. So with all of that in mind, we propose 3 lines of action on how we can actually mitigate all of this. And one, from the vendor side, we propose that all the device metadata and identifiers to be considered as a sensitive piece of information. We propose that there should be a privacy by design aspect in the local network as well, and promote as much as end-to-end encryption within the local network. Provide transparent and usable interface for control for the users, and include secure by design firmware and timely updates, and also harden the supply chain so third parties cannot just hijack over the data that's being sent over. From the policy side, we recommend that there was a lightning talk yesterday on the EU Cyber Resilience Act, and similarly GDPR in the Europe be more considerate about this kind of threats as well. And we include more third-party auditing and certification process as well, along with standardization efforts from IETF and including RIPE. For researchers like me, I want to suggest that we should look more into the security and privacy threats resulting from the integrating elements. We should develop more testing methodologies and assist vendors and independent auditors, and design more effective and usable security and privacy controls. So that being said, let me conclude my talk by stating that we are the first ones to characterize local network communication within 93 smart home IoT devices and 2,000 apps. We found several sensitive information being disseminated in the local network. We found that these devices can be used for fingerprinting and information harvesting. And we have responsibly disclosed all of these issues to all the responsible parties. And thank you. I'm open to take any questions now.